Okay, thanks for joining me for chapter 3.3, which is transformations of functions. Okay, if you have not watched the YouTube video, on all across the graph, you should pause this one. You should go watch it. You should get the lyrics from me, and you should know that song because that song is going to be very, very helpful in doing this. Okay, so we start with this being our equation here that transforms every function. Okay, and in this we do it in a certain order. And our order is H, B, A, K. Okay, so the H in this equation, okay, we'll say opposite. The opposite of H goes left and right. Okay, so this is a horizontal shift left and right. B is a horizontal stretch or compress. Okay, if B is bigger than 1, it's a compress. If B is a fraction between 1 and 0, it is a stretch. And if B is negative, you flip it over the Y. So then we'll go to, so that's H, B, we'll go to A. A is a vertical stretch or compress. Okay, if A is bigger than 1, it's a stretch. If A is a fraction, it is a compress. And if A is negative, we flip it over the edge. And the last thing we have is K. K goes left and right, so it's a vertical, K is a vertical shift up and down. Positive up, negative down. Okay, so this is the basis of everything that we do. And our goal is that right there. You should be able to look at that and tell me what the parent function is and how to go about graphing it. Okay, so we'll start here with something kind of easy. Okay, f of x equals x plus 2 squared. So our parent function is x squared. Okay, and then we look down our list here, H, B, A, K. Okay, so in this case I have an H, so H tells me to go, in this case it's the opposite of H, so the opposite of 2 would tell me to go left 2. I have no B, I have no A, and I have no K. So we start with our parent function, which is on that sheet I gave you, which looks something like that. And it tells me to go left 2. So there would be my function. We have g of x equals x squared plus 2. All right, so again, my parent function is x squared. And I have no h, I have no b, I have no a, all I have is k out here. So that k would tell me it goes up 2. So start with the parent function. We're going to go up 2 spots. And there's our new function. Again, these aren't exact graphs. These are just general ideas of what we want to look at. So we start with parent function. This is the square root of x. We've got the square root right there. So h is on the inside. So this tells me left 3, no b, no a, but I have a k. So that means down 4. Since it's a negative, that tells me to go down. So we have our radical parent function that looks something like that. We will go left 3, which would leave us at something about like that. And then we can go down 4, which would leave us about something like that, maybe. Okay. And I want a general graph here so that I can find domain and range. That's what we're really going to look for here on these types of problems. Okay, so let's try h of x equals negative x plus 1 squared. So my parent function is x squared. We start on the inside. I have this h, which is going to tell me left 1. I have a negative b this time. Remember, negative b flips it over the y-axis. I have no a and I have no k, so this is the only thing we're doing here. So we've got your parabola. We have left 1. And then we will have it flip over the x-axis. So you're going from this one, you're going to flip it over the x-axis, or the y-axis here. So the red would be your answer in this case. Try a little bit more difficult one here. Okay, so our parent function is the square root of x. So then we start in here. So notice that these are flip-flopped, and that's okay. We just have to know that b goes with x and h is all by itself. So that's a positive 2. So that's left 2. The negative x flips it over y. I don't have an a out here. And then this one would be up 2. Or sorry, up 1. So we've got our radical here. We're going to go left 2. Should be there. We'll flip it over the y-axis. Should be there. And we're going to go up 1. So it'd be right about in there. Okay. And you can check these on a graphing calculator if you would like. We're just getting a general idea so that we can tell domain and range here later on. So we've got a couple more here. So f of x equals 2 sine of x. I'm not sure if you were able to see those at the bottom there. That's what we were looking at on those two. I think I forgot to move it. So our parent function on this one, we talked about not needing to know sine of x, which is okay. This is sine of x. It oscillates between 1 and minus 1. So we have no h, we have no b, but we have an a. And in this case, a out front here is a vertical stretch. Since it's a whole number, okay, if that was a half, it'd be a shrink, okay? And what that does is it takes all of these values and pulls them away from the x-axis. So instead of being at 1, now we're at 2, and we're at negative 2. So now we're oscillating right there, and that blue line is your graph. So then we have g of x equals negative sine of 2x. Okay, again, your parent function is sine of x, which is that same graph, between 1 and minus 1. And in this case, I don't have an h, I have a b though. So this is a horizontal shrink or compress by 2. This flips it over the x, that's an a, and I don't have a k out there. All right, so if I think about an accordion here, we're just taking this and we're squeezing it down to my y. Okay, so I'm going to have this cycle right here happen in half of the space since it's divided by 2. And then I have to flip it over the x. So we'll flip it over the x. And that red line there would be my actual answer. Okay. Now let's go back to our goal real quick. Our goal equation right here. So we start with the parent function. What's the absolute value of x? And we start right here. So h means left. 2, the opposite of h goes left and right. B in the name is a horizontal stretch or shrink. So this is a shrink. So horizontal shrink by 3. Then we go to A. A is a vertical shrink or compress, whatever you want to say, by 2. Since it's a half, we're going to shrink it by 2. It also flips it over the x-axis, and we will go down 4. Okay, from that minus 4. So we've got our absolute value, which starts out as a v. And then we will move it left 2, right there. We will horizontally shrink it by 3. So what I'm doing is I'm squeezing it to the y-axis by a third. So I'm taking all of these and dividing it by 3. So this one's going to be 2 divided by 3, which would be 2/3. So it's going in here. So I've got kind of this pretty steep looking graph there. And then we're going to vertically, so that was a horizontal shrink. Now we're going to vertically shrink it by 2. So now all these are compressing down to the x-axis. So it's going to appear to get wider, but it's not necessarily getting wider. Okay, it's compressing down to that x-axis. Then we're going to flip it over to the x, so something like that. And then we're going to go down 4. So it should be about in here somewhere. Okay. Now again, that's not exact. That just helps me to realize that, okay, my domain is negative infinity to infinity. My range is now minus infinity to minus 4. And that's kind of what we're looking at. Okay, so these are going to take a lot of practice. You can make these up really easily. Just plug in numbers wherever you want, and it should you should be able to figure out, okay, this is H, this is B, this is A, this is K, and go from there. So here's your suggested problems. No challenge problem on this one. Just make sure that we can do this goal problem from the notes. As always, thanks for watching. This is at THS Mr. Jones signing off.